Hello? Today we're embarking on an epic journey through time to explore the fascinating history of natural gas. This invisible, odorless substance has shaped our world in more ways than you might imagine. From powering ancient rituals to fueling our modern cities, natural gas has been at the heart of human progress for thousands of years. But what exactly is natural gas? Before we dive into its history, let's take a moment to understand what we're dealing with. Natural gas is primarily composed of methane, along with smaller amounts of other hydrocarbons like ethane and propane. It's formed deep beneath the Earth's surface when layers of decomposing plant and animal matter are exposed to intense heat and pressure over millions of years. As we journey through the history of natural gas, we'll see how human understanding and utilization of this resource has evolved. We'll explore ancient myths and legends, groundbreaking discoveries, technological innovations, and the profound impact natural gas has had on global economies and geopolitics. Our story begins thousands of years ago in a world very different from our own. Imagine you're an ancient traveler, perhaps a merchant on the Silk Road or a pilgrim on a sacred journey. As you trek through rugged landscapes, you suddenly see something extraordinary: flames erupting from the ground itself. These natural gas seeps, often ignited by lightning strikes, must have seemed like magic or divine intervention to our ancestors. These mysterious flames played a significant role in many ancient cultures and religions. In ancient Greece, for example, the famous Oracle of Delphi sat above a natural gas fissure. The priestess, known as the Pythia, would inhale the vapors rising from a chasm in the rock. These fumes, now believed to have been ethylene, a component of natural gas, were thought to give her prophetic powers. The ancient Greeks built an entire religious tradition around this natural phenomenon, but Greece wasn't the only place where natural gas left its mark on ancient cultures. In India, the eternal flame of Jwalamukhi Temple in Himachal Pradesh has been burning for centuries, fed by natural gas seeping from the ground. Similarly, in modern-day Iraq, the ancient Zoroastrians built a temple around a natural gas seep, creating an eternal fire that burned continuously for centuries. Meanwhile, on the other side of the world, ancient civilizations in the Americas were also encountering natural gas. Native American legends speak of burning springs around Lake Erie, where gases bubbling up through the water could be set alight. These phenomena were later witnessed by French explorers in 1626, marking some of the first recorded observations of natural gas by Europeans in North America. But it was in ancient China that we find the first practical uses of natural gas. As far back as 500 BC, Chinese engineers were already putting this resource to work. They discovered natural gas while drilling for brine to produce salt. Using hollow bamboo poles, they constructed crude pipelines to transport the gas from shallow wells. The gas was used to boil brine, separating the salt and making it easier to extract. This process made salt production more efficient, which was crucial as salt was a valuable commodity used for preserving food. Some historians believe that this early use of natural gas may have contributed to China's technological advancement during this period. The ancient Chinese didn't stop at using gas for salt production. They also developed gas-fueled burst bamboo cannons for warfare. These weapons used the natural pressure of the gas to propel projectiles, showcasing an early understanding of the energy potential of this resource. It's fascinating to consider how these ancient encounters with natural gas shaped early human understanding of the world. In many cases, these seemingly magical flames reinforced religious beliefs and mythologies, but in others, like ancient China, they sparked innovation and technological advancement. For centuries, natural gas remained more of a curiosity than a widely used resource. The technology to effectively capture, transport and utilize it on a large scale was still far in the future. These ancient discoveries represent humanity's first steps in a relationship with natural gas that would eventually reshape the global energy landscape. The journey from these ancient flames to the natural gas industry of today is a testament to human ingenuity and our endless quest to harness the resources around us. As we leave the ancient world behind and enter the Middle Ages, natural gas continued to be a source of mystery and occasional practical use. However, the understanding and utilization of this resource remained limited throughout this period. In Europe, where much of the recorded history from this time originates, there are few mentions of natural gas. This is likely because natural gas seeps are less common in Europe than in some other parts of the world. However, there were some notable exceptions. In the 13th century, a Franciscan friar named Roger Bacon wrote about a pocket of air in England that burst into flames when ignited. This is one of the earliest recorded observations of natural gas in Europe. But without the means to capture or transport it, such discoveries remained little more than curiosities. Meanwhile, in the Middle East, natural gas continued to play a role in certain regions. The eternal flames that had been revered in ancient times continued to burn, maintained by natural gas seeps. These sites often became important religious centers with temples built around them. In 1626, French explorers visiting what is now New York State witnessed a fascinating phenomenon. Native Americans showed them burning springs around Lake Erie, where natural gas seeping into the water could be ignited. The French were amazed by this sight, which seemed to defy the natural order as they understood it. This encounter is one of the earliest recorded observations of natural gas by Europeans in North America. A few decades later, in 1659, natural gas was discovered in Britain, again by accident. A water well digger in Wigan, Lancashire, noticed bubbles rising to the surface of the water he had drawn. Curious about this strange occurrence, he touched a flame to the water, and to his astonishment, it ignited. This discovery caused quite a stir, but again, without the technology to harness it, the gas remained a local curiosity rather than a useful resource. Throughout the 17th and 18th centuries, similar accidental discoveries occurred across Europe and North America. In 1698, John Clayton, Dean of Kildare in Ireland, conducted what might be considered the first scientific experiments with natural gas. He collected gas from a coal mine and demonstrated that it could be stored in animal bladders and later ignited. Despite these discoveries, natural gas remained more of a scientific curiosity than a practical fuel source for most of this period. However, the groundwork was being laid for future developments. The scientific revolution of the 17th and 18th centuries brought new ways of understanding and investigating the natural world. Scientists began to study gases more systematically, laying the foundation for later advances in chemistry and physics that would be crucial to the development of the natural gas industry. For example, in 1785, Dutch chemist Jan Peter Minkelers discovered that gas distilled from coal could be used for lighting and heating. While this was coal gas rather than natural gas, many of the principles and technologies developed for coal gas would later be applied to natural gas. As we approach the end of the 18th century, we're on the cusp of the Industrial Revolution. This period of rapid technological and social change would create both the demand for new energy sources, including natural gas, and the technological capabilities to utilize them. The story of the modern natural gas industry begins in Fredonia, New York in 1821. William Hart, a gunsmith and inventor, had heard tales of a burning spring near the town. Intrigued, he decided to investigate. Hart reasoned that if gas was seeping naturally from the ground, he might be able to access more of it by digging. With this idea in mind, Hart set about digging the first intentional natural gas well in the United States. It was a modest affair by modern standards, just 27 feet deep, but it was successful. The well produced enough gas to light several street lamps in Fredonia. This achievement earned William Hart the title Father of Natural Gas in the United States. But more importantly, it demonstrated that natural gas could be intentionally extracted and used as a fuel source. Hart went on to form the Fredonia Gas Light Company, the first of its kind in America. While Hart's well was a significant milestone, the natural gas industry was still in its infancy. The gas could only be used close to where it was found, severely limiting its potential. Throughout much of the 19th century, it was coal gas, not natural gas, that dominated urban lighting and heating. Coal gas, produced by heating coal in the absence of oxygen, could be manufactured in cities where it was needed. By 1850, many major cities in Europe and North America had gasworks producing coal gas for street lighting and increasingly for domestic use. But natural gas had some advantages over coal gas. It burned cleaner and brighter, and where it was available, it was often cheaper as it didn't require manufacturing. These benefits drove continued interest in finding ways to use natural gas more widely. In 1859, an event occurred that would have profound implications for the natural gas industry. Edwin Drake drilled the first commercial oil well in Titusville, Pennsylvania. While Drake was looking for oil, his well also produced natural gas. This began a pattern that would continue for decades, natural gas often being discovered in the process of drilling for oil. As the oil industry boomed in the latter half of the 19th century, more and more natural gas was discovered. Initially, this gas was seen as a nuisance. It was often simply vented or flared off as waste. But gradually, entrepreneurs began to see its potential. One of these was Andrew Mellon, who would later become US Secretary of the Treasury. In the 1880s, Mellon and his brother Richard invested in a company that built an 87-mile pipeline to transport natural gas from the Pennsylvania oil fields to Pittsburgh. This was one of the first long-distance natural gas pipelines, and it demonstrated the potential for transporting gas over significant distances. The real game changer for the natural gas industry came in the early 1890s with the invention of leak-proof pipe couplings. This might sound like a small thing, but it was revolutionary. Previous attempts at long-distance gas transport had been plagued by leaks, which were both wasteful and dangerous. With leak-proof pipes, suddenly it became feasible to construct much longer pipelines. This opened up the possibility of transporting natural gas from remote fields to cities hundreds of miles away. The modern natural gas industry was born. In 1891, the first long-distance natural gas pipeline was built in the United States. It ran 120 miles from central Indiana to Chicago. This pipeline demonstrated the viability of large-scale natural gas transport and set the stage for the rapid expansion of the industry. By the turn of the 20th century, natural gas was starting to make significant inroads as an energy source. In 1900, it provided about 4% of the energy consumed in the United States. This might not sound like much, but it represented a huge increase from just a few decades earlier. The early 20th century saw continued growth and innovation in the natural gas industry. In 1908, the first natural gas compressor station was built in Illinois. Compressor stations, which pressurized gas to move it through pipelines, allowed for even longer distance gas transport. However, challenges remained. While we were getting better at finding and transporting natural gas, storage was still a significant issue. Unlike oil, which can be easily stored in tanks, gas requires specialized storage facilities. This made it difficult to manage supply and demand fluctuations. Additionally, the inconsistent nature of natural gas discoveries, often as a byproduct of oil drilling, meant that supply was unpredictable. Much of the gas found alongside oil was still simply burned off as waste, a practice called flaring that continues in some parts of the world today. Despite these challenges, the foundation had been laid for the explosive growth of the natural gas industry in the 20th century. The ability to transport gas over long distances opened up new markets and drove increased exploration and production. As we move into the 20th century, we'll see how natural gas transforms from a marginal energy source to a key player in the global energy landscape. The story of natural gas in the 20th century is one of technological innovation, changing energy markets, and growing environmental awareness. The foundations laid in the 19th century, the ability to drill for gas intentionally, the development of long-distance pipelines, and the growing recognition of natural gas as a valuable resource would now bear fruit in a big way. By 1920, natural gas provided 15% of the energy consumed in the United States. It would continue to grow throughout the century. Several factors contributed to this rapid growth, such as improvements in drilling technology, growing pipeline networks, new applications of natural gas, and economic factors. Natural gas was cheaper than other fuels in many areas of the nation. However, the rapid growth of the industry also brought challenges. The 1920s oil boom in Texas and Oklahoma led to the discovery of vast natural gas reserves. But much of this gas was simply flared off as waste because there wasn't enough pipeline capacity to transport it to markets. This waste caught the attention of conservationists and government regulators. In the 1930s, several states began to regulate natural gas production to prevent waste. The federal government also got involved, establishing the Federal Power Commission, now the Federal Energy Regulatory Commission, in 1935 to regulate interstate natural gas sales. Despite these challenges, the use of natural gas continued to grow. By the late 1930s, natural gas pipelines crisscrossed much of the United States. This expanding network made natural gas available to more consumers and industries than ever before. The growth of the natural gas industry had profound effects on American society and industry, such as expanding residential use, increased use in industry, electric power generation, and urban development, where heating was the most prominent usage. The growth of the natural gas industry also spurred innovation in related fields. For example, the need to store natural gas led to the development of underground storage facilities. In 1915, the first underground natural gas storage facility was developed in Welland County, Ontario, Canada. This technology would prove crucial for managing the seasonal fluctuations in gas demand. Despite these advances, there was still a significant problem facing the natural gas industry: the inability to store large quantities of gas efficiently. This limitation meant that gas production had to closely match consumption, which was not always possible. As a result, significant amounts of gas were still being wasted. This waste was particularly pronounced in the oil fields. As oil production ramped up in the early 20th century, vast quantities of associated natural gas were discovered. Without the means to transport or store this gas, much of it was simply burned off or flared. This practice, while wasteful, was considered necessary for safety reasons to prevent dangerous buildups of gas pressure. The flaring of natural gas in oil fields became a common sight, with some fields burning off enough gas to light entire cities. This waste was not only economically inefficient but also raised environmental concerns. The sight of these eternal flames in oil fields would become a symbol of the challenges facing the rapidly growing oil and gas industry. As we move into the middle of the 20th century, we'll see how these challenges were addressed and how natural gas would come to play an even more significant role in the global energy landscape. The post-World War II era would bring new technologies, new uses for natural gas, and a golden age for the industry. But it would also bring new challenges, including environmental concerns and geopolitical complications. As we emerge from the devastation of World War II, we enter what many consider the golden age of the natural gas industry. The post-war economic boom, coupled with technological advancements and expanding infrastructure, set the stage for explosive growth in natural gas use. In the United States, the interstate pipeline network grew from 220,000 miles in 1950 to over 900,000 miles by 1980. This massive expansion of infrastructure made natural gas available to more consumers than ever before. By 1970, natural gas had overtaken coal as the second most consumed energy source in the US, behind only oil. Several factors contributed to this rapid growth. Among others were improved exploration and drilling techniques, that natural gas was cheaper than alternative fuels, government deregulation, and environmental considerations, which was used as an argument against coal. During this period, natural gas found new uses beyond heating and cooking. It became a key feedstock for the petrochemical industry, used to make plastics, fertilizers, and a wide range of other products. This opened up entirely new markets for natural gas and further drove demand. In homes, gas appliances became increasingly common. Gas stoves, water heaters, and central heating systems offered convenience and efficiency that many consumers found attractive. By the 1960s, the all-gas home was being marketed as the height of modern living in many parts of the United States. The 1950s and 60s also saw significant advancements in natural gas storage technology. The development of liquefied natural gas, LNG, opened up new possibilities for long-term storage and long-distance transport of natural gas. In 1959, the world's first LNG tanker, the Methane Pioneer, carried a load from Louisiana to the United Kingdom, proving that natural gas could be transported across oceans. This breakthrough would have profound implications for the global natural gas trade in the coming decades. The rapid growth of the natural gas industry during this period wasn't without its challenges. As demand for natural gas grew, concerns about supply began to emerge. In the United States, gas shortages in the 1970s led to curtailments for some customers and spurred efforts to increase domestic production and improve energy efficiency. These shortages also highlighted the growing importance of natural gas in the broader energy landscape. As we move into the late 20th century, we'll see how the natural gas industry adapted to these challenges and how global events would reshape the industry once again. But that's a story for our next section. As we enter the 1970s, the natural gas industry faces a period of significant challenges and transformative changes. The energy crises of the 1970s had a profound impact on all energy markets, including natural gas. In 1973, the Arab oil embargo sent shockwaves through global energy markets. While the embargo primarily affected oil, it had ripple effects throughout the entire energy sector. Natural gas prices, which had been relatively stable for decades, began to rise sharply. In the United States, the situation was compounded by domestic natural gas shortages. Years of price controls had discouraged exploration and production, leading to declining reserves. During the exceptionally cold winter of 1976 to 77, these shortages became acute, forcing schools and factories to close in some areas due to lack of heating fuel. These crises sparked several important developments, such as further deregulation of natural gas markets, energy efficiency concerns which favoured natural gas, security of energy supply, which became a concern after the OPEC embargo, and increased exploration due to higher energy prices. The 1970s also saw growing environmental awareness, culminating in the first Earth Day in 1970. This increased focus on environmental issues would have lasting impacts on the natural gas industry. On one hand, natural gas benefited from being seen as a cleaner alternative to coal and oil. It produces less carbon dioxide when burned and fewer pollutants like sulfur dioxide and particulates. This led some to view natural gas as a bridge fuel that could help in the transition to renewable energy sources. On the other hand, the environmental impacts of natural gas extraction and transportation came under increasing scrutiny. Concerns were raised about methane leaks, water pollution from drilling operations, and the landscape impacts of pipelines and other infrastructure. The 1980s and 90s saw continued evolution in the natural gas industry. Technological advancements improved every aspect of the industry, from exploration and production to transportation and use. These were three-dimensional seismic imaging, horizontal drilling techniques, improved pipeline technology, and more efficient gas turbines for electricity generation. This period also saw the development of unconventional gas resources. Coalbed methane, tight gas, and shale gas started to be exploited, although they remained a small part of overall production during this time. Globally, the natural gas trade continued to expand. More countries began developing LNG export facilities, while others built regasification terminals to import LNG. This growing global trade helped to link previously separate regional gas markets. As we approach the end of the 20th century, the stage is set for perhaps the most transformative development in the recent history of natural gas: the shale gas revolution. As we enter the 21st century, the natural gas industry is about to undergo a transformation that few could have predicted. The combination of two technologies, horizontal drilling and hydraulic fracturing or fracking, would unlock vast new reserves of natural gas, particularly in shale formations. While both these technologies had been used separately for decades, it was their combined application to shale formations that proved revolutionary. Horizontal drilling allowed wells to follow the thin layers of shale where gas was trapped, while hydraulic fracturing used high-pressure water, sand, and chemicals to crack the shale and release the gas. The results were dramatic. In the United States, where the shale revolution began, natural gas production increased by more than 50% between 2005 and 2015. This surge in production had far-reaching effects, such as lower prices due to increased supply, higher demand from the electricity industry. It provided a competitive advantage to American industry and made America energy independent. The next chapter in this story is yet to be written. How will we balance the benefits of natural gas with the urgent need to address climate change? Thank you for joining us on this journey through time.